Welcome back, team. Thank you for joining me today. Today, we're going to continue on our cargo planning calculations. And today, we'll be looking at stability and moments. This is our phase 6 of cargo planning calculations. Now, this vessel is considered to be in a stable position. Here, km is the distance from the keel to the metacenter as km. Kg is the center of gravity where weight is acting vertically downwards. Kb is the center of buoyancy where displacement is acting vertically upwards. Gm is the metacentric height which determines the condition of the vessel. Here if we at any point should have a large GM, the vessel would be considered to be stiff. That means too much weight would be near the keel or in the lower hold. If the GM is small, then we would have a tender ship. That means too much weight would be on the twin deck or the upper deck. It is good to have a suitable GM, not too large, not too small, so that your vessel will not experience any of these conditions. Now, let us look at moments. Here, moments is a force times distance. It is also known as torque, which is the turning effect of a force. So moment can either be in a clockwise direction or an anti-clockwise direction. Here we look at the system where the principle of moment is expressed. Here you have a focal point or a pivot, and you have D1 is the distance from the pivot, perpendicular distance to where the weight W1 is. And that would be in an anti-clockwise moment. On the right, you will see a distance D2, perpendicular distance from the pivot to W2, weight 2, and that would be in a clockwise direction. So that would produce a clockwise moment. Let us look at an example. We know that moments is equal to force times distance, right? In this figure, we have a system where on the clockwise side, we have 50 newtons acting in that direction, 6 meters from the pivot. On your left, where the anti-clockwise moment is acting, we have 80 newtons, which is 4 meters from the pivot. Let us find the total moment for such a system. Our solution reads, first let us calculate the clockwise moment. That would be equal to the force times the perpendicular distance, which would be 50 newtons times 6 meters, which gives us 300 Newton meters. Let us look at the anti-clockwise moment, where we have 80 newtons times 4 meters, which gives us 320 Newton meters. To find what the system is actually doing, or the total moment of the system, we would need to find the difference between both moments. And so we'd have the 320 Newton meters minus 300 Newton meters. That would result in 20 Newton meters in the anti-clockwise directions, since that moment was greater than the clockwise moment. Now that was short and spicy. So let's stay tuned for phase 7 of the cargo planning calculation, where we're going to be talking about finding final kgs, final GM, and RM. And remember, continue to support Lane's ED enhancement by subscribing, liking, and sharing with your colleagues. See you soon. Phase 7 coming up.